Hi everyone, welcome back. Today we are diving into another important LeetCode problem. In this video, we will start by carefully reading the question, understanding its constraints, and laying the foundation for our solution. Once we have mapped out approach, we will bring it all together by coding the solution step by step. So without further ado, let's get started. Let's begin by breaking down the problem description. Given an array of positive integers nums and a positive integer target, so there is an array of positive integer nums. There is a positive integer target. So let's just start noting down the information from the problem description. And we have to find the minimal length of subarray whose sum will be greater than or equal to target. So to start solving this question, first we have noted down all the information from the question, and to start with it, we will first try to get a brute force solution as quickly as possible. And then we identify any bottlenecks and look for ways to optimize our approach for better performance. We will take an example and we will try to solve it manually, like in our mind how we are going to solve it if we will be given us such array and such question. So let me take an example here. The example should be generic enough. It should not contain any special cases. Make sure and target, suppose target is 30. So how we will going to approach this question now is um, we will try to solve this example and then we will build our solution from that, and then at the end we will code it. Suppose the constraint of survey is not given, okay, right? And maybe think that question is given like this, right? Like this is you have given an array and you have to find integer from the array whose sum will be greater or equal to target. So in this question, what we are going to do is we will pick up the the, the greatest integer value from the array and we will compare it with target. So in our case, we will take 30 and we will compare with target. And this value will already be greater than or equal to target. So we will get length as 1. So solution of this question will be 1, right? And suppose we have a target as suppose 40. Then how we are going to solve it? So what we are going to do is we will take 30, and since 30 is less than 13, we might need to we will pick the other next greatest element from the array, that is 19, and sum of these two will be 49. It's greater than or equal to 40, right? So we will get our answer that is equal to 2. Now, with constraint of subarray given, how we are going to approach this, solve this problem. So the thing here is without subarray given, we are picking the greatest element. So with subarray, can't we pick a greatest element? The answer is no. We can't simply pick a greatest element because the constraint of subarray will be broken with it. See, if we choose 30, right, then 19 and 30 will not create a subarray, right? So what we want to do is we want to take a window of items, right? And the size of window should be as small as possible. Then, how do we create a window inside an array? So you might already be aware that if we take two indexes, right, suppose I and j, then we can think of like value, whatever values inside these two indexes, it will be creating a window, isn't it? So, so what we are going to do is we are going to create window. Okay. How many way we can create a window? If we create two for loops, one for I and another for j, then we will able to create all the sets of windows, right? All the combination of windows, and we can get the answer. We can sum out the values within the window and we can compare with the target, and then we can minimize the length that way. Okay, now you will ask that how do we know what will be the sum within the target? So for that, we will use another sum array of n size where sum I will be sum of values from nums nums 0 plus nums I, right? And sum of I, j minus I will be um, sum of j minus sum of I plus nums I. That will include I also. So, but the problem with this approach is the t- time complexity will be big of n into n, and with the constraint given that num's length will be less than or equal to 10 power 5, n square is not acceptable. It will end up creating TLE, time limit exceed error. So we have to find a quicker solution than this. Now the bottleneck is having two for loops right here. Can't we like optimize this? Now what we are thinking is, do we really need to iterate through having two for loops and iterate through all the possible windows? Answer is no, we don't need. Like, so basically, to get a size 40, we will first start appending integer item one by one to the summation, and until we find values, sum of window values inside the window get equal to target, we will not stop. We will simply keep adding item to it. Now, once we get the sum, what we will do is we will keep popping out the oldest item, because such way that we can find a optimal solution, right? Because after adding the uh, rightmost item, we have sum getter equal to target. So we may not need the items which we have added initially. Okay, so in this case, we will keep decreasing the windows, keep decreasing the window size, keep decreasing the window size, and when we reach size as 2, again the sum is less than equal to target. So in that case, we again keep adding item or window. Also, at each step, we will keep track of the number of items in the window. Whenever the sum of all items within the window is greater than or equal to the target, we will update the min length value. Now that we have devised our approach, let's start. Let's move on to coding. Now that I have written the code, let me start explaining this. Okay, so first we will have to int value ij. This is basically two pointers for the sliding window, and there is a variable called min length which will track the minimum length of the window in which the sum of all the values will be uh, greater than equal to target. We have initialized larger value that is greater than the maximum length of the nums length array. And then there is an unsigned int sum which will be storing the sum of the elements in the current window. Then we have a while loop which will be used to expand the window size by moving j rightward. Then we start with adding the value of um, uh, item at j into the sum, and then we will try to shrink the window from the left by incrementing the value of I. So when we found out that the sum of the items inside the window is greater than equal to target, then there is a possibility that if we will shrink the window, then also we will might have the sum greater equal to target. Then we have this code to track that. After this, if we have a window which sum is uh, less than target outside this window, then we will increment the j. Now at the end, we will check if min length is equal to the max uh, size which we have sliced here. If the value of min length is equal to the larger value which we have initialized here, that means we haven't found the answer. So in that case, we will return with 0 as per the description. Otherwise, we will return the min length here. Now let's analyze the time complexity and the space complexity of this approach. So as per our algorithm, right, we are going to insert each item inside the sliding window only once, and we are going to pop out each item only once from the sliding window. That means the time complexity taken by this while loop is going to be big of and all. Now about the space complexity, we are using min length, I and j int value, and then unsigned int sum. So space complexity will be big of 1, that is constant. So let me try to submit this code. Let me first run this code. Let's see. Okay, let's submit it. I hope you like this video. Thanks for watching this. Let's meet in the next video.